Okay, so we're ready to try the scope, and there it is there. It's got no signal coming into it right now, so it's, there we are. That's my finger doing that. Okay, so we're going to keep an eye on both of these guys while I perform this test here. Let's turn on the radio. Better get out my meter manual here, 6A7. Get it open to the right page, because I think I'm going to have to look at the pins to figure out where to put my scope in order to see if 6A7, here we are, right down here. Just put that aside. I think we're all set here. Let's switch on the radio. There we go. Now this hot chassis thing would be a crisis right at this point, because I have a ground wire connected over to my scope, and I think what would happen, I'm not absolutely sure, if I left the power switched on but I clicked it off with this switch, I would at that instant be applying a short straight across the power line. You know, it doesn't make sense to me. I have to sit down and look at the circuit diagram, but let's just say that these hot chassis radios, nothing is quite as simple as it might seem when you start introducing other grounds and the like. Okay, so it should be warmed up. There we go. So let's try out. Oh, there's that sound again. If I had some freezy spray, I might have some fun with that. But oh, I think I just what's that? Okay, don't know where the lightning's coming from, but it's coming. I haven't even hooked up the scope yet, so while we're looking at it. So first thing we will do with the scope, in order to see if we can find the oscillator. Now I gotta warn myself here. Look at the size of these resistors in the circuit. 15 megohms, 50 megohms, 40 megohms. Gee, you know what? I was looking at this earlier and thinking, oh my god, this thing is loaded with gigantic resistors. 500 megohms. I mean, these are huge resistors. 500 megohms. But M, in some epochs of history, M really stands for mille, which is French for 1000. This makes a lot more sense. That this is really not 500 megohms. It's 500K. So I think in my head I've been thinking, oh my god, look at that. In my head I've been thinking, oh my god, look at the size of the resistors in this thing. Okay, so I got that cleared away. There we go. So what's that telling us? It's telling us we want to get onto the grid that has the oscillator circuit in it, and it's the second grid in the two. The second grid has the oscillator signal on it. The second grid is pin number 4. 1, 2. Yeah, G2. Pin number 4, and pin number 4. Oh no. I was gonna say. Oh man, pin number 4. I was gonna say, look, it's right beside the little nubbin on the key. But no, that represents, that little thing there represents the grid cap. So pin 4 is never next to the nubbin or the key. So pin 4 shouldn't be too tough to find. And this tube up here. What did I do with my other camera? I've lost. Oh, it's aimed at the scope, crying out loud. Okay, so let's take a look at both these things at once here. And I will attempt to find pin number 4. Uh-oh. Uh-oh, uh-oh, uh-oh. This is not the kind of tube that has a key. This is a pre-octal tube. So I gotta go 2 fat pins, mark the heaters. 2 fat pins. And one more clockwise is pin number 1. Is that right? The one that's more clockwise is pin number 1. Okay, so 2 fat pins. 2 fat pins walk into a bar one day. Okay, 1. So if that's correct, if I got it correct, that's 1, 2, 3, 4. This is 4. This is 4. Maybe this might be a little noisy too. Let's see. One, two, three, 4. Not particularly noisy. Okay, let me clip right on here. I see a good spot. Now, there's high voltage here too, so I don't want to... No, there shouldn't be any high voltage here. Okay. Well, I'm not sure actually. Grid number 2. Ah, diggity dog, look what we got on the screen there. Boy, if that doesn't look like an oscillator, I don't know what does. Okay. I'll tune the radio, we'll watch the oscillator change. And you see a couple things going on there as I tune the radio. Let's see if I can just twist it a bit here. You can get a look at the dial. Let me change the camera angle here. Okay, I think that's stable enough for this. So here we go. So you can see it getting, the signal getting louder or bigger, and the frequency going down. Oh, now we've hit that point. But see, it's not. Oh, it's doing something there, isn't it? Like there's a DC component popping in and out. My scope is set to AC right now. Let's put it on DC. Hey, where'd it go? Okay, one moment, let's ground it. Come on, a little switchy. Okay, so that's the ground point. Let's move it right to the center. DC on. So you can see there's a DC voltage there of something like 2, 4, 6, 8 volts. 8 volts. Now we'll tune it. So nothing happening to the DC voltage. Now we get up close to this funny spot and right there. Nothing happens. Oh, a very tiny amount. That is a very tiny effect. So I don't think that that's going to be provide us too much guidance on what's going on there. Well, the oscillator is working. Let's switch bands. And we'll put this back to AC. And we'll switch bands here. Where now you see a much, much higher frequency. Let's see if I can get individual. I like that up. There we are. So there's the individual frequency. We'll tune again. You'll watch it change. So there's a local oscillator. Ooh. Look at that. Stopped oscillating. And it oscillates fairly nicely. We don't know what frequency that is, of course. This could be way off. You know, I would like to be able to feed these things right into a frequency counter, but the front end of the frequency counter is low impedance. It's really looking for a fairly strong signal. So I think we can calculate this frequency from my scope. Wow, I don't know about that. I really don't know about that. One thing's for sure, the shortwave local oscillator frequency is way higher than the AM one, and now we've proven the band switch too. There's AM, and there's shortwave. So I don't think we have any problem with the oscillator. And we're seeing it right on the grid of the tube. You know what? The message is this tube is not working right. I think we really need to test this tube at this point. So I think that's what we're going to do here. Let's shut off the power. And we'll just go back to where we were. Back to where we were. Pop that tube out and test it. So how about I'll get all set up for that, and then we'll see what the results are on that tube. Okay, so I'm going to look up the tube here. My tube tester has a roll type chart on it, but I don't like to roll the chart. So I have a electronic copy of it here, which is what I normally refer to. I really don't like to roll that chart. So we're talking about a 6A, 6A7. Oop. 6A. Oh, how's this listed? 6A goes into letters. There's no 6A7 on here. Maybe it's at the other end of the sixes. Sometimes they maybe they number it that way. 6H, 6J, a lot of sixes. 6S, I'm at the end of the list now. See, if you were doing this on a roll chart, it'd drive you nuts, rolling it back and forth. Being driven nuts as it is. So 6A7 now. Let's go right to the start here. 6. So here's the end of the sixes. 6Y. Yeah, there's no 6A7. Okay, let's try a different roll chart here. Because these tube testers came out with, you know, the information they had at the time the tube tester was made, and then, you know, a year later they got an update. So let's try this. Let's see if we can find a 6A7 on here. Additional tube data. Two, three, 6A. Hey, 6A, come on. 6A7, there it is. Excellent. Okay, so now we've got the 6A7 here. So that's what I go through each time I try to, I want to test a tube in my old tube tester. My old tube tester is this guy here. My favorite tube tester. So 6.3 JR. Let's get that right for sure. 6.3 JR. Okay, so that sets the the heater terminals. 02365. 02365. 0, 2, 3, 6, 5. 0, 2, 3, 6, 5. Double check. 0, 2, 3, 6, 5. 22 and 50. 22 on the bias. 50 on the English. We'll set the English here. And we're all set. This is a 7-pin tube. I think it's going in here. No, maybe here. 1, 2, 3. This one here. Okay, those are the two big pins. What's up? Okay, let's try this one. 1, 2, 3, 4, 5. No, this is a 7-pin. 1, 2, 3, 4, 5, 6, 7 pins. 1, 2, 3, 4, 5. Oh, that's 6. 4, 5, 6, 7, 8. Is that how this works? So 1, 2, 3, 4, 5, 6, 7. This is the one. This is the one here. There it goes. A little hard to get in there. Okay, it should be heating up. Oh, I gotta turn it on. Okay, that would help. Always helps to turn things on. And now you can see it. I don't know if you can see it in the camera. Just look right in past here. You can see the heater going. Oh no, it has a grid cap. I've got to connect a grid cap onto that. That's a bit of a hassle. My grid cap connection is broken up there. Wow. Okay, so I need a big clip to get on that grid cap. Okay, this is not quite the best way to do it, but it'll work. And you may not see me do this on camera too often, but I check these clip leads regularly when I'm using them. So here's the grid cap wire, which I cannot really see. You probably see better in the camera than I see here. Okay, we're connected. We're good to go. I think we're good to go. So we'll check for shorts first. We're in the clear. And now, watch your eyes on this meter. It's in the good. It's a goody, goody, goody. But that's only one part of the tube. Not to be fooled here, because there is another part to this tube. So we'll set up for that. 5436 with a 2. Same heater, of course. 5436 with a 2. 5, 4, 3, 6 with a 2. 5, 4, 3, 6 with a 2. 30 and 73. 30 and 73. Very good. Oh, lots of extra information here on this particular tube. What's this say? Oscillator section. Micromos only. OK over 240 on 3000 scale. Come back here. Don't go away on me. So read that again. Okay, the target value is 300. oscillator section, micro modes only, OK over 240 on 3000 scale. Okay, so we'll put it on the 3000 scale. So it's saying don't use the English. It's on the 3000 scale, and it should be anything over 240. And 240 is way down here. Huh. Strange that they would have it kind of set like that, eh? But I guess there's something peculiar about it. We're all set though. Check for shorts. Ain't none. And I think it's P4 for the test. Press P4. Here we go. P4. There it is. Just as predicted. So, nothing wrong with this tube. I don't know whether to be happy or not. Well, we'll put that back in the radio. I don't think there's any reason to suspect any other tubes at this point. And apparently there wasn't even a good reason to suspect this one. You might wonder why I just don't pull every tube out and test every tube. And you know, you can do that. I tend to operate sort of on an evidence-based approach, where I'm looking for some hint all the time on what I should do. Sometimes you kind of just have to do things for the sake of doing them, just to get them out of the way, or ensure you're not having trouble. I'm working just out of the view of the camera there. Well, that didn't work for us. So what do we got? We still have a radio that appears to have no front end for some reason. So I don't think it lies in the tube. I don't think it lies in the coils or the antenna. The next thing we're looking at, it's a whole whacking pile of capacitors in here. So I think what I'll do is I'm going to stop for a moment and ponder this a little bit, and try and come up with the next plan on what to poke around, what to check. So, and I think I'll post these videos too. See you later.